Hello students, welcome to ICSE Computer Applications for Class 10 Programming in Java. This is part 4 of the revision of work done in class 9. This is the fourth part and the last part for revision. Okay, what did we do in the last session? In the previous session we did the conditional constructs, in which we did the if else ladder, switch case, default and break statements. In the current session we will be doing the for loop, while loop and do while. Okay, now what are loops? We have already done loops. We will be just revising them, but maybe there are a few things you will come to know for the first time now. Okay, what are loops used for? Loops are basically used to repeat something. So that means if there is a statement you want it to be repeated a number of times, how would you repeat them? You would repeat them using a construct called loops. Now please remember, suppose I want to display hello on the screen 5 times. I can, if I don't know loops, then I can probably write down system.out.println hello once and maybe copy paste it 5 times or 4 times. The total number will come to 5 and it will display hello on the screen 5 times. But that is not how we are going to do it here, because I have said 5 times. It could be 500 times, it could be 5000 times. I don't think you will be copy pasting it that many number of times. Okay, the construct used is loops, and there are 3 kinds of loops in Java. The first loop is a for loop, second is a while loop, and third is a do while loop. Majority of the time we will be using the for loop, but we will be using while loop also sometimes, do while rarely, but yes, you should know about all these things, all these 3. Okay, so what is for used for? For is used for repeating a fixed number of times. So that means if you want to ask for marks from 10 students, you know there are 10 students, you know the number is fixed. So what loop will you use? You will use a for loop. Okay. The second is a while loop. While loop is basically used for repeating until a condition becomes false. Now I don't know when actually I start the loop, I don't know how many times this loop is going to work. Alright, for example, there are people entering a theater, I am counting them, and I will end the count when there is nobody else coming into the theater. Okay, so do I know how many people are actually going to come into the theater? I don't know. So I cannot use the for loop because that is for fixed number of times. I will then use a while loop. So this is called an entry control loop. I'll explain it in a while. Next is do while. Do while is the same as while, but this loop always executes once at least. So that means there is a condition here also, but the condition is given at the end. That is why it is called as an exit controlled loop. It controls at the exit of the loop, not at the entry of the loop. So in a while loop there is a condition given at the entry of the loop, whereas in a do while it is given at the exit of the loop. So that is why it is naturally going to execute at least once, because when it enters the loop body it doesn't know the condition. It comes to know of the condition only when the exit condition comes into play. Okay, let us understand the for loop. This is not the syntax of a for loop. I am explaining the for loop to you here. Now you will see that in this particular logic, you will find that there is a statement given before the for loop. The for loop is here, and the for loop starts from this brace and ends on this brace. Okay, this statement is given before the for loop and this statement is given after the for loop. Okay, now please remember there are 3 statements here. One is this statement, that is before the loop. This is this statement inside the loop, and this is the statement which is given after the loop. The before the loop statement and the after the loop statement are going to be executed only once. Now the for loop is written in such a way, you write for, there are round parentheses, round brackets, and inside the round brackets there are three things written. We have an initialization part, we have a condition part, and we have a modification part. Now, how do these statements execute? Okay, first of all, when we run this program, this statement is going to be executed first. After this statement, the initialization part will be executed. That means the variable will be initialized. After this, the condition is executed. It checks whether the condition is true or false. The condition may be true, the condition may be false. If the condition is true, it enters the loop body. And if it is true, and if it is false, it exits from the loop body. So that means if the condition is false, it comes out of the loop body. Okay, as I told you, the loop actually ends here. So when it reaches this part, from here it goes back to the modification part. So that means now after the statement has been executed once, it goes back and executes the modification part. From the modification, it goes into the condition part, and if the condition is true, goes into the loop. If it is false, it goes out of the loop. Okay, I hope it is clear. Let me execute this once again. This statement will be executed. From here it goes into initialization, from here into condition, from here into the loop body or out of the loop body. If it is inside the loop body, it goes back into modification, from modification into condition again, and from condition again, if it is true, into the body or out of the body. Okay, now this is the real program. I have written the same statements, but there are some things that I have actually filled in now. We have a system.out.println start, which when executed will display start on the screen. This will display end on the screen. In between these two statements is the loop. This loop basically requires a variable to actually count how many times the loop is going to execute. So which line is going to be executed first? This start statement is going to execute first. Then a variable called x is going to be created. For loop starts, x is going to have an initial value of 1. The condition is till x is less than or equal to 3. This loop will go on and on and on till x is less than or equal to 3. The moment it becomes more than 3, this loop will terminate. Okay, so how does this happen? It displays start on the screen. Then it creates a variable called x, and it comes here. X gets a value of 1. Then it comes into the condition. Is the condition true? Yes. 1 is less than or equal to 3. It enters the loop body, displays x. X right now has a value of 1. This is the end of the loop. Naturally, it is going to go back into the modification part. The modification says, okay, modify x, change it to 2 now. X is now 2. Now when x is 2, it comes here to check the condition, whether the condition is true or false. It is still true. 2 is less than or equal to 3. It comes into the loop body and displays 2. The loop ends here, goes back, modification, x is now 3. 3 is less than or equal to 3 is true. It displays 3 on the screen, comes here again, x is now 4. This condition now becomes false because 4 is not less than or equal to 3. Now, the moment this is false, the loop terminates and the statement which is written after the loop is executed. So it displays end when the loop finishes. Okay, I hope this loop is clear to you. I have made a little modification, a small modification here. Instead of creating the variable x before the loop started, I have created the variable right inside the initialization part. We can do both of them. Very true. So this loop and the previous loop actually did the same. They are going to do the same. This is also going to display start and then 1 2 3 and then end. Okay, now what is the difference between the two? Now what is the difference between the one that we created first, that is the int variable was written before, and this one? Let me explain that to you. If I create the variable x like this, the variable has been created outside the for loop, so its scope is outside the for loop. The scope is throughout the program now. Okay, but if I do not do this, so that means if I create this loop here, this variable here, now the variable has been created inside the for loop. So if it is created inside the for loop, it can be used only inside the for loop. It cannot be used outside the for loop. For example, if I try to display the value of x here, will it display the value of x here? No, it will not. It does not know about x here. Why? Because x has not been created outside the for loop. That means before the for loop, it has been created inside the for loop. So it can be used only inside the for loop. Please remember again, if I create a variable inside the for loop like this also, this also has been created inside the for loop, and if I say give it a value, say is equal to 10, and I try to display y here, will y be displayed now? No, y will not be displayed again. Okay, why? Because the scope of y was only inside the for loop. It cannot be used outside the for loop. When this closing brace exits and it reaches this place, the variables x and y, both of them are already dead. Okay, I hope you have understood that part of the program. Let me see how much you have understood. I have given a small program here. I would like you to pause the video, look at this program properly, and find out what is going to be the output of this program. Let me make a small modification. This x has already been created, so I will remove this from here. The program is perfectly fine now. Okay, now the x variable is being displayed here and inside the loop and after the loop finishes. So please tell me now, what is going to be the output of this program? What is it going to display here? What is it going to display here? And again over here. You can pause the program. Okay, now that you have unpaused it, let us see what this program is going to do. X is a variable which has been created outside the for loop. Yes, that is why it is going to display something here also, over here. Now x is having a value of 2. Over here it displays 2. When the loop starts, x again gets the value of 1. Now the value of 2 is gone now. X is now having a value of 1. This loop is the same as the one that we did earlier. So this will actually display 1, 2 and 3. What is it actually going to display here? You can understand why did the loop terminate? Loop terminated because x had a value of 4 when it finished, when the last x was increased. X was 4. That is why this condition became false and it came out from here. So it is actually going to display a 2, then a 1, 2 and 3 here, and then a 4 here. Okay, so let's compile this program, close it. And let's run this program. When you run this program, you will find that it has displayed 2, that is before the for loop started, then 1, 2, 3 inside the for loop, and 4 after the loop had finished. Okay, the next statements are break and continue. Break, as you have already done in the switch statement, So break can be used in the switch statement also, and break can be used in all the loops also. Okay, so break, as you know, terminated the switch. Here also break inside the loop terminates the loop. Okay, so break is used to terminate a loop. It does not matter whether the condition is still true. So if the condition is true, doesn't matter. If a break statement is executed inside a for loop, it will automatically terminate the loop. Next is a continue statement. Continue statement is used to move the control to the loop header. That is for x is equal to 1 and so on and so forth. That is called as the header. So it again reaches the header. It will skip all the statements after the continue statement. So if there are statements after the continue statement, then they will not be executed. It will go back to the header again. And please remember, break and continue are always used inside an if. That means they are always conditionally performed. You cannot openly write a break or a continue. Otherwise, it is going to be a meaningless task. Okay, let me explain to you the working of the break statement. As you can see, we have a variable called x, which starts from 6, goes up to 10, is increased by 1 every time, and it displays the value of x inside the for loop. The additional thing that we have done here is we have given a break statement, and break is given in a condition if x is greater than or equal to 7. So if it is x is greater than or equal to 7, it will perform the break statement. So let's start off. X is 6 in the beginning. Is 6 less than or equal to 10? Yes, it displays 6. In the if condition, is 6 greater than or equal to 7? No, break will not execute. Okay, so x will become 7 here. Is 7 less than or equal to 10? Yes, it displays 7 here. Now, is 7 greater than or equal to 7? Yes. Okay, because it is equal to 7 now, it will perform the break statement. So break statement will be executed, and if the break statement is executed, it will terminate the loop and go out of the loop body. Please remember, it doesn't matter whether the condition is still true. 7 is less than or equal to 10 is true. It will still terminate the loop. Why? Because of the break statement. Okay, let us copy this into our program and see the working of it. Okay, let's compile this and execute it. You will find that it displays only 6 and 7. Okay, so why did it not display 8, 9 and 10? Is because this condition was true, and it actually allowed the execution of the break statement, which made it to terminate the loop. Okay, now about the continue statement. In the continue statement, if the continue statement is executed, from continue statement it goes back to x plus plus again. Alright, here for x is equal to 6, x is less than or equal to 10. Normally it should have displayed 6, 7, 8, 9, 10, but let's see how continue will change the behavior of this loop now. X is 6. Is x percent 2 equal to 0? Is x divisible by 2? Yes. So continue statement will be executed, and it will automatically go to x plus plus. X will now become 7. Is 7 less than or equal to 10? Yes. Is 7 an even number? No. So continue statement will not be executed. Okay, and it will automatically display x, that is 7. So please remember, it has actually displayed only two numbers, 7 and 9. Why did it not display 6, 8 and 10? Why? Because x was even in those cases, and continue was executed, and automatically it went back to x plus plus again. It never allowed the rest of the statements to be executed. So it skipped, as I told you, it skipped the rest of the statements after the continue statement. I hope those two statements were clear, break and continue. I have combined both these statements into one program. Let me see what your what you think of this. You can pause the video now and figure out what is going to be the result of this, and after we come back I'll give you the result. Okay, we are back now. I have already compiled the program, so let us see what is going to be the output. Let us figure out what is going to be the output. When x is 1, you can see the break statement will be executed only when x is greater than or equal to 6. So that means when x is going to be 1, 2, 3, 4 and 5, it will remain inside the for loop. It is only when x becomes greater than or equal to 6, when it becomes 6, it will actually come out of the for loop. Okay, so the for loop actually is only working on numbers 1, 2, 3, 4 and 5. Okay, this statement will be executed only if this continue statement is not executed. So when will it allow it to go? So when x is even, it will actually go back. So all the even numbers are not allowed here. So what do you think is going to be displayed? It is going to display out of 1, 2, 3, 4 and 5, it is going to display only 1, 3 and 5. Let us see now what is going to be the result. The result is 1, 3 and 5. It has displayed only these three numbers. Okay, let us now understand the concept of accumulators and counters. The accumulators are basically variables which are normally variables, but they accumulate stuff. For example, int s is equal to 0, so s is 0 to begin with. If I write s plus equal to 3, s is now increased by 3, s becomes 3 now. S plus equal to 2, s becomes 5 now because it is now again increased by 2. So if I try to display s now, s will be displayed as 5. So what is s working on now? It is working on accumulation right now. Okay, now similarly we have a variable called c, which is now working like a counter. C is 0 to begin with, and if I write C++, it is increased by 1. If I write C++ again, it is again increased by 1. And if I try to display C here, it is actually going to display 2 because it has actually increased by 1 twice. So it will become 2 here. Okay, my first program now, after learning how to accumulate and count, is going to be to find the to write a program to find the sum of numbers 1 to 10. 1 to 10 basically gives a sum of 55. So let us understand how to do this. First of all, how many numbers are we actually summing up? We are summing up 10 numbers, and the numbers are going to be 1 to 10. Can I generate those numbers 1 to 10? Yes. How do I generate them? I generate them using a for loop. So naturally, for that I need a variable called x, and I'll write x is equal to 1, x is less than or equal to 10, x plus plus, and inside the loop body I'll not write anything. Inside the loop body, what do you think is going to be the value of x? X is always going to have values 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, what am I going to do with those numbers 1 to 10? I am going to accumulate them. So what do I need? Before the loop, I will create an accumulator called s, which has a value of 0, and inside the loop body I will write s plus equal to x, that is x will be accumulated into the variable s every time, and when the loop finishes, system.out.println s is displayed after the loop finishes. Okay, so what is going to how are things going to happen here? What is the for loop doing? For loop is generating the numbers 1 to 10. What is s doing here? S is accumulating all those numbers. It is inside the loop body, so it will be executing 10 times, and in the first loop it is going to accumulate 1 into it, then 2, then 3, then 4. So that means it will keep on accumulating all these numbers, and when the loop finishes, it displays X here, S here. Okay. Now the rules for accumulation and counting. Number 1, whatever accumulator or counter you use, you will always create it before the loop starts, and you will also initialize it. Secondly, you are going to count or accumulate inside the for loop, and then you are going to use it outside the for loop. That means you are not going to display S inside the for loop, you are going to display it outside. What happens if I now remove S as that println from here and put it here? It is actually going to display 10 numbers to me. It will display first 1, then 3, then 6, then and so on and so forth. Okay, so I don't want so many numbers. I actually wanted only a single number, which is the sum of all the numbers 1 to 10. Okay, my next program. I want to write a program to basically count even numbers from 1 to 10. I want to count them. There are 5 even numbers from 1 to 10. I want to count how many are there. So what do I need now? I basically need numbers from 1 to 10. For that I will use a for loop. I have created a for loop. The for loop is generating the numbers from 1 to 10. Now inside the for loop I need to count. So naturally I need a counter. So I will create a counter and initialize it to 0 before the loop starts. Inside the for loop I could probably write a C++ basically to count the numbers. Now if I do like this, it is going to count every time. Doesn't matter whether it is an even number or an odd number, so it will basically count 10. Okay, but I want only even numbers. So that means I want C to be executed only when X is an even number. How do I check whether X is an even number? So I check X %2 is equal to 0. If X is an even number, please increase C by 1. Okay, so C will be increased only when X is an even number. After the loop finishes, we display the value of C. Okay, so what this program is now counting even numbers from 1 to 10. Now the rule is the same that applied to the previous one. For counting, again we initialize a variable to 0 or anything before the loop starts. We increase it inside the for loop and we use it outside the for loop. I'm using the word use it after the for loop. I'm never saying display it after the for loop. Are we clear? Okay, it will be clearer in the next program. Okay, now my program has changed now. The program is write a program to find the average of numbers 1 to 10. To find the average of numbers from 1 to 10, what do I need? I need the sum of all the numbers. I need how many numbers? I basically know there are 10 numbers. Let's count them in the program itself. So what do I need? I need a counter and I need an accumulator. So that means I need an accumulator also and I need a counter also. So I've created both the variables. I'm not concerned with even or odd numbers. So that means I will increase the value of S plus equal to X also and C++ also. Now what is going to happen? S plus equal to X is going to accumulate all the numbers. C++ is going to count all the numbers. So if I divide S divided by C when the loop finishes, it will actually should be giving me the result. It should. Okay, so what I'll do is I'll create a variable called float avg is equal to S divided by C. If I write it this way and display avg, is it going to work fine? I think it is going to work fine for the time being, yes. So S is increased by X every time, C is going to be increased by 1 every time. So S upon C, that is the sum of all the numbers divided by count of all the numbers. It is being stored in AVG and AVG is being displayed here. on the face of it, this program is looking very fine. But please remember, the variable ABG is going to be a float variable. Why? Because it is actually going to give me something upon something. So that means if there is a division, there is bound to be a fraction somewhere. So naturally I have created as a float. But ABG is a float variable. But what is the data type of S? S is an int variable. What is the data type of C? C is also an int variable. So if S is an int, C is also an int, what do you think is int divided by int? It is going to be an int. So as I told you earlier, S is going to be 55. 55 upon 10 should give you a 5.5. But do you think ABG is going to store 5.5? No, because it is not receiving a 5.5 from this division. Why? Because this division is incapable of giving a decimal result. Okay, is it understood? As I told you earlier, that an int divided by an int will give me the result as an int. So it is going to give me 5 as a result, not 5.5 as a result. Okay. So what do? I typecast it. Okay. So I'll typecast S as a float. So I'll write float before the S divided by C. So S is now being treated as a float in this expression. So float divided by int, the result is a float, so it becomes a 5.5 and ABG gets a 5.5. So the result is a 5.5. Okay. I hope this is clear to you, because you've already done typecasting, so I am just brushing things up. My next program, display factors of a number. N is the number whose factors are to be displayed. Factors basically are those numbers which completely divide a number. So which are the numbers which completely divide 10? 10 is divisible by 1, 10 is divisible by 2, 10 is divisible by 5. So 1, 2 and 5 are considered factors of 10. 1, 2 and 5. Okay, understood. How are we going to do this program? Now please remember, 10 is not a factor of 10. That is not what I consider it to be. So how do we do it? How do I display the factors? Please remember, if I have 10 as the number, what do you think is the largest factor of this number? It's going to be 5. If I have 20 as the number, which is the largest factor of this number going to be? That is 10. That is half of 20. Suppose if I write 50, what is the largest factor of 50? It is going to be 25. So please remember, the factors will never go beyond half of the number. So that means my first priority should be to generate all the numbers from 1 to half of that number. Okay. How do I do it? I've already created a variable called x. I know 1 is going to be the smallest factor. I know that half of the number is going to be the largest factor. I'll increase it by 1 every time. Okay, so what am I going to do here? What is this loop going to do? This loop is going to generate all the numbers. Please remember, I'm using the word generate again and again. It is generating the numbers 1 to 5. So numbers 1 to 5, okay. But 1 to 5, all the numbers are not factors. If I just write system.out.println and x, is it going to be fine? I don't think so, because this is going to display 1, 2, 3, 4 and 5. All the numbers are not actually factors of 10. So what do? I allow the x to be displayed only if n is divisible by x. So if I divide n by x and the remainder is a 0, then it must be a factor. That means it is completely divisible. Okay, my program is done. Okay. Now please remember, x is going to be displayed only if this if condition allows it to. And what is this if condition getting? N it is getting from outside, that is the value of 10, it never changes. X changes every time because it is inside the for loop. So x starts with a 1, It checks whether 10 is divisible by 1. Yes, it displays 1. Then it becomes x becomes 2. Is 10 divisible by 2? Yes, 2 is also displayed. It becomes 3. Is 10 divisible by 3? No, 3 is not displayed. Okay, so this program is displaying factors of a number. Okay, I hope this program is clear to you. This for loop is clear to you. Some of the questions that I will be asking you will be actually dependent on this program. So please understand this properly. If there is any question, you may ask me in the comments below. Okay, I'm going to stop this session at here only. The while loop and the do while loop we will be doing some other time, not at the moment, because I want you to be doing some really grueling work that we should be doing. Okay, not doing all the revision at the moment. So while and do while we'll be doing sometime later. So we'll stop at for loop now. I hope for loop is very clear to you. I will be asking you questions in a PDF file. I'll send a PDF file also along with it, and I would like you to answer them. Okay, I'll stop here. The next time we meet, we will be doing functions, and before we do functions, we'll also have an online test. Okay, I intend to have an online test somewhere next week, so I'll fix things up and then talk to you about this later. Thank you. I hope you enjoyed the session. I did. Thank you guys for listening.